Until this point, we've talked a lot about lines and how they work. For example, we've talked about what equations look like of a line. We've talked about if I graphed this line right here, what the y-intercept is, what the slope is, what that looks like in the equation. So the natural thing to do, once you know everything about a line, is start comparing lines to each other. So today we are going to talk about finding the equations of parallel lines. And we start with the definition. Two lines are parallel if and only if they have the same slope and different y-intercepts, which makes sense because if I had another line, say this blue line, and I had a y-intercept right here, but the same exact slope as the green line, you could see that if those two lines kept going on forever, they would never meet. They would be parallel to each other forever. However, it does specify that we need different y-intercepts, which also makes sense because if I were to shift this blue line up to have the same y-intercept as the green line, they would no longer be parallel, they'd be identical, they'd be the same line. So, we know that two different lines must have the same slope and different y-intercepts. And we can use that to answer questions. We can use that to find the equations of lines that are parallel to each other. For example, we have write the equation of the line that is parallel to the graph of each line and passes through the given point. So in this case, we have an equation and we have a point. We want to find the line that has the same slope as this one, the line that's parallel to this one, but passes through this point. So we can assume that point is not on that graph. So let's start by graphing our first line. We have y equals 3x plus 6. So I know immediately my y-intercept is 6. I'll put that right here. This is the point 0, 6. 1, 2, 3, 4, 5, 6. And I just need one more point on this line to graph it. So I'm going to plug in some random x value. This time I'll do -1. -1. When x equals -1, we have y equals 3 times -1 plus 6. Which gives me y equals -3 plus 6, which is 6 minus 3, which is equal to 3. So we have the point -1, 3. So our line looks kind of like this. But we want to know the equation of the line that is parallel to that one that passes through this point. So what do we know? We know whenever we're looking for a line, we write down everything we know. I have y equals mx plus b. And I'm looking for the equation of a line that's parallel to this. Well, parallel means it has the same slope, which means I have the same slope as this one, which is 3. So I have y equals 3x plus b. And now I need to find this b. I need to find what my y-intercept is. And luckily, we have a point on our line that we can plug in to find the y-intercept. So I plug this point in. I plug in 7 for y, so I get 7 is equal to 3 times x, which is 4, plus b. Or 7 equals 3 times 4 is 12, plus b. Subtract 12 from both sides. And I get b is equal to 7 minus 12 is 12 minus 7 with a negative sign. And 12 minus 7 is 5. So my line is, the equation of my line ends up being y equals, our slope is still 3x, and we know that b is -5, so 3x minus 5. So this line looks like this. 1, 2, 3, 4, 5. We have that y-intercept. And that's all there is to it. We use everything we know to find the y-intercept, and then we're done. So let's try one more example. Y equals x minus 4, and we have the point -2, 3. So we have a given equation, and that given equation has the graph -4, 1, 2, 3, 4. And if we plug in the point 4, we know we have 0 because 4 minus 4 is 0. So let's just go to x equals 4. 1, 2, 3, 4. Find the x-intercept. So this is our given line. And we want to find a line that's parallel to it that has this point as a part of it. So we know we have our slope of 1. So I get y equals x plus b. I don't know what b is yet, but I have my given point, so I plug that point in, and I get 3 equals negative 2 plus b. Add 2 to both sides, and b equals 5. So we have y equals x plus 5. And this is the equation of this line that has the same slope as this one, but passes through the given point. And that equation looks like this, x plus 5, so 1, 2, 3, 4, 5. Point right here, same slope. And those are our two lines. Now, what happens if you have something that's not in slope-intercept form yet? If you have an equation that looks like this. In this case, all you have to do is put it in slope-intercept form, which is always y equals mx plus b, so we know we want y to be alone. So we subtract the 2x from both sides. And we get y equals mx negative 2x plus b plus 4. And we're already back in slope-intercept form and ready to go. And I don't have my given point. What's my point here? My point is going to be negative 1, comma 2. I want a line that is parallel to this one that passes through the point negative 1, comma 2. So let's try it out. We have a given slope of negative 2, which means this line, my y-intercept is 4, 1, 2, 3, 4. But if I plug in the point 1, I get y equals negative 2 plus 4, which equals 2. So if I plug in x equals 1, I get y equals 2, and we see that my line is actually negative this time. It has negative slope. Looks like it's going downhill. So my new line that passes through the given point, negative 1, comma 2, is also going to have a negative slope because it's going to have the same slope. So we have y equals negative 2 plus b, negative 2x plus b. We can plug our point in. 2 equals negative 2 times negative 1 plus b. Negative 2 times negative 1 is just going to equal 2 plus b. Subtract 2 from both sides, and we actually get b equals 0 this time. So our equation is just going to be y equals negative 2x, which means I have the point here, and then I have the point 1, comma 2. Negative 1, comma 2. That makes a lot more sense. And then we can see that my lines are parallel to each other. And that is how you find the equation of a line that is parallel to a given line if you also have a given point.